This is the second video for the Rational Expressions unit, Chapter 6, in which we're going to focus on simplifying rational expressions. So the key thing to remember pretty much any time you're doing anything with rational expressions is that they're basically just fractions. And you can simplify them basically just like fractions. It's obviously going to be a little bit more complicated because you're going to be dealing with polynomials and variables and all that. But the idea behind it and the processes behind it are basically going to be the same. So let's start by just looking at a regular fraction, something like 20 over 30. So remember, if you want to simplify this, you want to divide the top and the bottom, the numerator and the denominator, by the same thing. There are options here, right? You could divide by 2, you could divide by 5, but the best option is the largest, which is 10. So we're going to divide the top and the bottom of this by 10 to get our simplified version, which is 2 over 3. The idea is going to be basically the same for our rational expressions. So if we wanted to simplify, say, something like x squared over y to the power of, or x squared times y to the power of 4 over x cubed y cubed, and I'm just going to give you some NPVs here so we don't have to worry about it. So x can't be 0 and y can't be 0. We're going to simplify these essentially the same way that we'd simplify anything else. So I'm going to break this up more than I normally would just to kind of explain the process, and then I'll teach you a slightly faster way to do this in a sec. So x squared, right, is x times x. Y to the power of 4 is y times y times y times y. And then we've got 3 x's and 3 y's in the denominator. So to simplify this, all we really need to do is cancel out common factors. Right, you're going to divide the top and the bottom by the same thing, which in this case is just going to be some x's and y's. So up top, we've got 2 x's, so both of those x's are going to cancel out an x in the denominator, like so. In the bottom, we've got 3 y's, so each of those is going to cancel out a y up top. And so we're left with 1 y on the top and 1 x on the bottom. And so our final answer is just y over x. Another way to do this would be to use exponent laws. So if we have x squared y to the power of 4 over x cubed y cubed, remember when you divide powers with the same base, you subtract the exponents. So x squared divided by x cubed is going to be x to the power of -1, and y to the power of 4 divided by y cubed is going to be y to the power of +1. And then you might hopefully remember from grade 10 that negative exponents, like we've got here, right? So this -1, they flip things. And so instead of this being x to the power of -1, y to the power of +1, this becomes y to the power of 1 over x to the power of 1, or just that same y over x that we had before. But there's actually even a better way to do this, and the way that I would normally use. It's basically the same thing, but it skips the negative exponents. And so we're still going to subtract our powers here, but instead of doing the top minus the bottom, how I would do it is I just do the larger power minus the smaller power. So for our x's, I'm going to do 3 minus 2, and then whatever's left just goes wherever you had more. So we had more x's on the bottom here, and so our extra x is going to be on the bottom. We had more y's on the top, so 4 minus 3 is going to get us 1, and our extra y is going to be on the top. And so that is how I would normally do it. So I'm just going to write out a quick explanation for that. So we're going to subtract the exponents and put the leftover wherever you had the larger exponent. And so for me, that's really generally the easiest way to go about doing it. The breaking it up way that we did first, it works, but it's time consuming and space consuming, especially once you start to get into larger powers or you have more variables. So I don't recommend it as a general rule, but it is an option. So let's look at a similar one, but just slightly more complicated. So if we've got 4 x to the power of 5 y cubed z to the power of 6 over 10 x to the power of 7 y to the power of 8 z. And so remember, when you've just got a bunch of variables multiplied together, your NPVs are all just going to be 0. So x can't be 0, y can't be 0, and z can't be 0. Okay, so again, we could break this all up into 5 x's, 3 y's, 6 z's on the top, and then a bunch of x, y's, and z's on the bottom, but that's going to take a really long time. So let's start with the coefficients. We've got a 4 and a 10. Don't try to use exponent laws to these. Don't subtract them. All you do is you just simplify these normally. Just imagine this was a fraction that was just 4 over 10. So just simplify coefficients normally. Okay, so 4 over 10, we can divide those both by 2, which is going to get us 2 and 5. Then looking at all of our other things, so looking at the x's and the y's and the z's separately. So for the x's, we just do 7 minus 5, right? So subtracting our exponents, which gets us 2. And so since we had more x's on the bottom, those 2 extra x's are going to be on the bottom. For the y's, we do 8 minus 3 and we get 5. And same idea, we had more y's on the bottom, so our extra 5 y's are on the bottom. And then for the z's, 6 minus 1 gets us 5, and we've got more on the top, so our z to the power 6 goes on top. So that is by far the easiest way to do these questions, in my opinion. Moving on. Most of the time we're not going to be dealing with cases like this where it's just a bunch of variables. A lot of the time we are going to have addition or subtraction. So let me give you one that's already been factored just to make our lives a little bit easier, and then we'll get into the more complicated ones after this. All right, so we've got a couple of polynomials that have been factored, and we've got x plus 2 times x plus 3 over x plus 3 times x minus 2. So to simplify this, all we have to do is just cancel out common factors. When I say common factors, that means factors that are exactly the same. So really all we're going to do here, if we've got our x plus 2 times x plus 3 over x plus 3 times x minus 2, we're doing this the same way we would any other fraction. We're just dividing the top and the bottom, in this case, by x plus 3. But when we do that, the x plus 3's in the numerator and denominator get canceled out. And what we're left with is x plus 2 over x minus 2. You cannot simplify these. So incorrect simplification is probably one of the most common mistakes in this chapter. You can't divide the top and the bottom by, say, 2 here, right? You can't cancel out these, because if you're going to divide by 2, you have to be able to divide everything by 2. So you can cancel out separate factors, things that are being multiplied together like we had here, right? So this and this are factors that are being multiplied by things, but once you get into addition, once something's being added with something else, you can't cancel out part of that addition. You have to cancel out the entire thing together. So we'll see cases like that in a little bit, but for now, just keep an eye on it and know you can't cancel these and try not to mess it up. Last thing we need to do is figure out our NPVs. So looking at our final answer here, we have x minus 2 in the denominator, so we've got an NPV of x cannot be positive 2. But that actually isn't our only NPV, and it's not going to be a negative 2 from that numerator because we don't care about the numerators. Our other NPV here is negative 3. So a really important thing to keep in mind, if something's an NPV at any point in a question, so we had that x plus 3 in the denominator at some point, so if it's an NPV at any point in the question, it will stay an NPV all the way through to the end. Just because you canceled things out doesn't suddenly make something allowed. So you've got to look through your entire question when you're trying to figure out what your NPVs are. And that's another thing that people tend to mess up. All right. So most of the time you are going to have to do your own factoring when you're doing these things. So as I mentioned in the last video, factoring is really going to be a crucial skill to do well in this chapter. So 2x squared plus 4x over x plus 2. So most of the time, we're going to start a question by factoring something. It won't always necessarily be the entire rational expression, but if we're trying to simplify like we are now, we definitely need to factor everything. So the denominator is good, right? X plus 2, can't do anything with that. Up top, 2x squared plus 4x, we can take out a common factor there. So we can take out a 2x from both of those things. And then when we do that, we are left with x plus 2. And so looking at that, we have x plus 2's in the numerator and denominator, so we're going to cancel those out. And we're left with just 2x. For NPVs, we have x cannot be negative 2, and that was the only thing that was in the denominator, so that's all we've got, and our answer is just this. All right, continuing forward. So 3x plus 12 over x squared plus 7x plus 12. So same idea. We're going to factor that numerator as much as we can. So we can take out a 3 as a common factor, which leaves us with x plus 4. And then we're going to factor the denominator as well. So multiplying to 12, adding to 7, that's going to be x plus 3 and x plus 4. A lot of the time in this chapter, you are going to get factors that are similar, because that's how we simplify things, and that's going to be important for doing adding and subtracting and other things. So if you're factoring and nothing seems to be matching up, there's a good chance that you've messed up somewhere, and just keep an eye on it. It doesn't necessarily mean anything, right? Sometimes just nothing's going to line up, but do keep an eye on things. Often we are going to get repeated factors in questions. Like here, we have x plus 4's in both. And so we're left with 3 over x plus 3. And so again, this is another one that we cannot simplify, right? You can't simplify any further because you can't divide all of the terms by 3. If, say, this had been 6x plus 3, absolutely we could divide everything by 3 and simplify this a little bit more. But we don't have that 6 there. It's just an x, and we can't divide all of our terms by 3, so this one doesn't go any further. It does need some NPVs, though. And so we get that x can't be negative 3 or negative 4 from this x plus 4 that we had in the denominator before. All right, so give this next one a shot on your own. You're going to probably run into a bit of a challenge on this one, and that's okay. So it's not necessarily a trick question, but it is kind of a trick question. I'll warn you in advance. So go ahead, factor this, simplify as much as you can, and then once you maybe hit a bit of a wall, come back and see what I have to say about it. All right, so if we factor that numerator, multiplying to negative 2, adding to negative 1, we've really got to be careful with our negatives here. This is going to be x minus 2 times x plus 1. And then in the denominator, we've got x plus 2 times x plus 3. So looking at that, if you're paying attention and you factored properly, you'll notice, hopefully, that none of these actually match. This does not simplify. Which happens, right? Just like fractions, sometimes things don't simplify. So like I said, a bit of a trick question, because you can't actually do what I asked you to do, but that's okay, it happens. We do have NPVs, once again, so x can't be negative 2 or negative 3. X squared plus 8x plus 15 over 2x squared plus 7x plus 3. So that numerator, multiplying to 15, adding to 8, that's just 5 and 3. That one's easy. The denominator, we have an a value that we can't take out. So you've really got to watch out for these because I know just from experience, that a bunch of people are going to mess this up when they're factoring. So I will give an example of this one just this one time, but in the future, you're going to have to do these on your own. So 2x squared plus 7x plus 3. So remember, we're going to multiply the 2 and the 3 together to get 6. And then we're going to find out what multiplies to 6 and adds to 7. So that's going to be 1 and 6. And so where a bunch of people are going to go wrong here is they're just going to factor this into x plus 1 and x plus 6. But if you look at these obviously don't match up with what we started with, right? X times x isn't going to get you 2x squared. So this is completely wrong. Don't do this, please. You need to be able to factor these things properly. What we are going to do is we're going to take that 7x and we're going to split it up into an x and a 6x. Then remember, we're going to make groups of our first two terms and our last two terms. We're going to take out common factors from those groups. So from the first two, I'm going to take out an x, which is going to leave me behind 2x plus 1. From the second two, I'm going to take out a 3, which is also going to leave behind 2x plus 1. I'm going to set aside those 2x plus 1s and combine what's left, which in this case is x plus 3, to get my second factor like that. And so everything's fully factored, and we've got this. We can see we've got that common x plus 3, so we're going to cancel those out, which is going to leave us with x plus 5 over 2x plus 1. And our NPVs are x cannot be -3 or -1 over 2. And so again, that -1 over 2, if we take 2x plus 1, we set it not equal to 0, and we solve that, we'd be subtracting 1 on both sides to get 2x cannot be -1, and we'd be dividing both sides by 2, which is going to get you that -1/2. All right, this next one is going to be for you to do, and it is going to have a lot of factoring going on. So be really careful with this. Take your time, factor it properly, and then come back once you're done. This one's not a trick. It will simplify if you do it right. So if something doesn't seem like it's working, double check your factoring again, and then come back. Okay, so 3x squared plus 10x minus 8. If you go through your entire process, that's going to factor to 3x minus 2 times x plus 4. In your denominator, you actually have a common factor there. You can take out a 2, and you really have to keep an eye out for common factors here, because if you don't take them out, you might not notice that you have things that cancel. So on the denominator, if you took out the 2 and then factored from there, you would have had x plus 4 times x minus 2. So if you didn't get any of those right, go back and double check your factoring again, try it one more time. And if you really don't get it, make sure you go back to chapter 4, look at the factoring review videos, and get a little bit more practice there. So here, we're going to cancel out the x plus 4s, which is going to leave me with 3x minus 2 over 2 times x minus 2. Again, those x minus 2s that you see are not going to cancel because they are not the same. For NPVs, we've got x cannot be -4 or +2. Remember, this common factor 2 that we pulled out doesn't affect NPVs at all because it's just a 2. Okay. 3x minus 9 over x squared minus 9. So up top there, you've got a 3 that you can pull out, which is going to leave you with x minus 3. On the bottom, we've got a difference of squares. So just as a quick reminder for factoring differences of squares, let me give you a more complicated one that we can talk about. So if you have something like 25 x to the power of 4 minus 81 y to the power of 6, right? This is a difference of squares where it's a perfect square minus another perfect square. To factor these things, you find the square root of the first thing. So the square root of 25x to the power of 4 is 5x squared. The square root of the second term is 9y cubed. And so your factored version of this is just those two things added together. So 5x squared plus 9y cubed. And then the difference of those two things, so 5x squared minus 9y cubed. And so you've got to notice and recognize differences of squares when they arise, because if you don't, you're just not going to be able to factor them. So in this case, that x squared minus 9 is a difference of squares. And so x squared is going to get us x, 9 is going to get us 3, so this is going to be x plus 3 times x minus 3. Those x minus 3s are going to cancel, and we're left with just 3 over x plus 3. Our NPVs are positive 3 and negative 3. And you could, of course, write that as plus or minus 3 if you wanted to. All right, last one, which is just going to have a slightly different thing that we do run into from time to time. I'm going to give it to you in factored form just to save us some effort. So looking at this, at first glance, nothing here is the same. X minus 2 and 2 minus x are not the same term, right? If I told you to do 5 minus 7 or 7 minus 5, you are going to get different answers. So we can't, at first glance, cancel anything here. What we can do is take this 2 minus x, and we're going to rearrange it a little bit, because I don't like the way that's written. So instead, I'm going to just switch the order there, and it's still going to be a negative x, and it's still going to be a positive 2, which gets me this. And then I don't really like having a negative at the front, so remember our leading terms in polynomials, typically we want those to be positive. So what I can also do is factor out a negative 1 in the numerator. And so when I do that, I'm going to get negative 1 times x minus 2. And then I still have that whole denominator down there. And so now I can cancel something out. But you can't do this until you've rearranged things and until you've taken out that negative 1. And don't just assume that that's always going to work. Sometimes I've seen people cancel out things that are completely different just because they assume this is going to end up happening. So you've got to go through the process and make sure you actually end up with a common factor here. So what we're left with is negative 1 over x times x plus 3. And we've got our NPVs of x cannot be positive 2, negative 3, or 0. And so there we go. That is how we simplify rational expressions. This is something we're going to do lots of, because after you add or subtract or multiply or divide, you're always going to want to simplify as much as you can. So make sure you've got a handle on this before you move on to the next few videos where we're going to start multiplying and dividing these things.